Hello there! So we are on to the next Physics 11 video. This one's all about speed, velocity, and acceleration. Let's jump right into this. So our purposes are to learn about speed, velocity, acceleration. Maybe you know a little bit about this already. And we're going to solve some problems involving all three of those. So speed versus velocity. Speed is the rate of change of distance, meaning how quickly your distance changes. This is a scalar quantity. So that means we do not have direction, we just have a number portion, and this is your equation, v equals d over t. V being speed, d being distance, t being time. Next we got velocity. There's a little arrow above the v that should tell you something already. So this is the rate of change of displacement. This one is a vector, and we write this as velocity equals displacement over time. So these are your two equations, one for speed, one for velocity. All right, so here's another example. We've got another cute pygmy monkey. If you haven't seen the pictures, they're really cute. I don't know how you haven't noticed the pictures. They're really tiny. So we've got a pygmy monkey, and it is traveling 10 meters west and then 4 meters east. And it's going to take 5 seconds for this monkey to do that. We want to know average speed, average velocity. Don't get thrown off by the fact it says average. We just want to solve this like we normally would. Speed is distance over time. The distance traveled here is 10 plus 4. Again, we don't care about directions. And we divide that by 5 since that's the time. This gives us 2.8 meters per second. To get velocity, we've got velocity equals displacement over time. Remember from last lesson, we did this whole long process with the arrows to figure out what our displacement was. So we're going to use that value to put in our velocity. I put in negative because it's west. So we get negative 1.2 meters per second. I do not want you to keep the negative in there. You need to put direction. Be as specific as possible. Again, remember, negative could mean down, it could mean left, it could mean south. You need to write in west so I know exactly what direction you're going. So this is our next example. This one does not involve a monkey. This one is involving a truck. And it says, how long does it take a truck that is traveling at 70 kilometers an hour to travel 380 meters? First thing we need to do is convert. If you didn't notice that, it says kilometers per hour. I want that in meters per second. Remember, that's our SI unit. Looking at your formula sheet, just take kilometers per hour divided by 3.6, you get meters per second. Again, it says how long, so it doesn't necessarily indicate anything about it being a vector. We weren't told directions, so we can assume this is distance and speed. Plug in numbers. With this, it's a little bit of algebra. So you're going to switch the t and the 19.4. And I put the repeating sign because I don't want to round into the very, very end. So the time it takes is 19.54 seconds. Last on our list of things to learn today is acceleration. So acceleration written as A with a little arrow thingy on top. This is the rate of change of velocity. So as indicated with the little arrow, this one is a vector. And here's how I write this equation. What the delta V means is it's change in velocity. That's how you write it. Delta just means change. And in equation form, it just means Vf minus Vi. So the final velocity minus the initial velocity. So anytime you have an object that has changing velocity, you have acceleration. Let's give an example here with another cute pygmy monkey. It starts from rest, reaches a speed of 4 meters per second in 7.1 seconds. We want to know acceleration. We have an equation. Change in velocity is just Vf minus Vi. Plug in some numbers, and we get acceleration. Notice in this question, I didn't give you direction. If I don't give you a direction in the question, you don't need direction in your answer. So we got another monkey. It's accelerating in the west direction for 2.2 seconds. If its initial velocity is 0.7 meters per second west, we want to know what its final velocity is. So here's the equation we used before. We have a bunch of these values. Notice I put in negatives for the acceleration and for the initial velocity. This is because those were in the west direction. Let's do some algebra. So times by 2.2 on both sides. Then we're going to subtract 0.7, and this is your final velocity. Again, don't leave this as negative. You want to indicate that this is in the west direction. So there is your final velocity. There we go. So that was a quick one. That is this lesson. This next clip is from one of my favorite movies, Star Wars Return of the Jedi. You might not realize I'm a huge science fiction and fantasy nerd, so Star Wars being one of my favorite series is the original trilogy, of course. The other ones aren't as great. Anyways, you can debate me on that. So this is another scene for you to analyze and just figure out whether the physics for this is true or not. Ignore the fact that spaceships, because we don't really have spaceships, ignore that fact. Look at the rest of this and see if there is any physics in this that you think is not correct.
Break off the attack. Shield is still up. I get no reading. Sure? Hold up! All craft, hold up! Information accurate. It's a trap. Coming in. Video. Accelerate to attack speed. Draw their fire away from the cruisers. Copy that.
Alright, so give it a sec. Think if there's anything in this that you think is not true or you think that is totally plausible. Okay, so other than the fact that we don't have spaceships, you can't fly around in spaceships, there's one glaring thing with this, and this actually ruins a lot of science fiction stuff, is in space, you can't hear noises. So all these parts where you hear the spaceships flying around or you hear the laser fire throughout the scenes, that actually doesn't happen. So as you've got other noises that are going on here, it actually, you wouldn't hear anything, it would just be silent. So even if you're inside of the spaceships, you would just hear silence inside the whole thing. So that would make for a very boring scene if you don't have any sound effects. So that's why, of course, they tried to put all those lasers and noises from the TIE fighters and stuff in there so you can actually hear and enjoy what's going on. So this one would be actually quite boring without those sound effects. So there you go. There's another example of bad physics, which doesn't diminish the movie for me. Just want to say that.